Today we will be solving quadratics by factoring. This is our first look at solving quadratics, so we need to discuss what that means. When we find the real solutions to quadratics, we're just finding where they cross the x-axis. In Algebra 1, we'll only be dealing with real solutions. So, for example, if you have a parabola like this, the two solutions, and this one would have two, would be right here where it crosses the x-axis. For example, you could have one solution. So let's say this parabola has its vertex on top of the x-axis there. That one would have one solution. And then for now in Algebra 1, we will just say this one has no real solution. The one in pink has no real solution. When you get to Algebra 2, you'll find imaginary solutions, but for Algebra 1, we're only focused on these. If you see one like this, we will just say no real solutions for that one. Alright, so this first example here, solve quadratics by factoring. This one is already factored. We have our two factors here and here. We have it set equal to 0. You must set it equal to 0. So we were basically finding where does this parabola, if we FOILed this out, we would get a quadratic. Where does it cross the x-axis? Well, the factors are going to tell us that. Well, we have two factors here, factor 1, factor 2. They're multiplied together and they equal 0. That means that at least one of them has to be 0. So this quantity right here has to be 0, or this quantity has to be 0. That's the only way you can multiply two factors together and get 0. At least one of them has to be 0. So we use that to our advantage and set each factor equal to 0, and then we will solve. So we'll set the first factor equal to 0, add 5 to both sides, 7a equals 5, divide by 7, and we get a equals 5/7. So in other words, this parabola crosses the x-axis at 5/7. Then we solve the second factor, so we add 3, get 2a equals 3, divide by 2, and we get 3/2. So this parabola has solutions at 3/2 and 5/7. That means it crosses the x-axis at an x value of 5/7 and 3/2. So if I quickly put this in my calculator, 7x subtract 5 factor 1, 2x minus 3 factor 2, and we graph it. So we have 3/2 and 5/7 there. If I graph y equals 0 and y2, find the intersections. Second trace, option 5. We'll just find 1. So 0.71428,571, and if we do 5 divided by 7, we're going to get that approximate decimal. So this parabola crosses at 5/7 and 3/2. That's what we're finding. Alright, example 2. This one actually is already factored. We have a factor of x and we have a factor of 5x minus 6. We already have this set equal to 0, so we just need to set each factor equal to 0 and solve. You must understand that x is a factor here. So we set that equal to 0 and it's already solved. So this parabola crosses the x-axis at an x value of 0. It also crosses when 5x minus 6, when that factor is equal to 0. So we add 6 to both sides, we get 5x equals 6, divide 5, and we get x equals 6/5. So 6/5 and 0 are the solutions, in this case the x-intercepts, for this specific parabola. Alright, next example, third example, x squared plus 8x plus 7 equals 0. We're solving by factoring. In the previous two examples, they were already factored for us. So we need to go back and remember how we factor. So we want two numbers here that multiply to 7 and add to 8. That is 7 and 1. In the past, we've put our little x here, and we put the multiply to number here, the add to number here. So what two factors of 7 multiply to 7, add to 8? That would be 1 and 7. So this factors to x plus 1, x plus 7. So a little quick factoring review there. So we set that equal to 0. If this is equal to 0, we can set this equal to 0 because they are equivalent. This right here is the same as this right here. So we set each factor equal to 0 and solve it. So we'll do that next. So these are pretty easy to solve. So x equals -1 is a solution, and if you see the pattern here, x equals negative 7 is also the solution. So if you notice the pattern, x plus 7 gives us a solution of negative 7. X plus 1 gives us a solution of negative 1. So they're going to end up being opposite signs in this case. So those are the two solutions. This parabola crosses the x-axis at negative 1 and negative 7. Okay, next example here. X squared minus 13x equals negative 40. We need to set them equal to 0 before we start factoring. So x squared subtract 13x plus 40 equals 0. We just add this 40 over here to the side. And now we factor. So we want two numbers that multiply to the last number, 40, and add to 13. So let's list factors of 40. 1 and 40, 2 and 20, 4 and 10, 5 and 8. And those are our only options. This one right here, this pair here, gives us 40 when we multiply and 13 when we add. So 5 and 8 are the two key numbers we need to use. So x plus 5, x plus 8 is how that factors. Oh, and I needed to make this a negative, didn't I? So these both need to be negative. So let's fix that. So x subtract 5, x subtract 8 equals 0. Just like before, we've got it factored. So we set each factor equal to 0 and solve it, and that gives us our solutions. X minus 5 equals 0. X subtract 8 equals 0. So x equals 5 here. You need to get used to shortcutting that little pattern there. And x equals 8. So this parabola crosses at x equals 5 and x equals 8. Okay, last example here. 3n squared plus 7n minus 6 equals 0. So we want to find when does this parabola cross the x-axis. So we are solving by factoring. It's already set equal to 0, so that's done for us. Now we just need to factor this thing. So we have a leading coefficient greater than 1. So the way we did that is split and group. So we multiply first times last, and that would be a negative 18. So we want to multiply to a negative 18, and we want to add to the middle number 7. So factors of 18, 1 and 18, 2 and 9, 3 and 6, and those are our only options. Now we have two, well actually here it is right here. So 2 and 9. So 2 and 9. This number is negative, so 1 is positive, 1 is negative. The bigger one always gets the sign of our addition here. So we have a positive 7, so that means that one's a plus, that one's a negative there. So split it into those two pieces. So subtract 2n plus 9n minus 6. Now we've split it, so now we group it. So we group these two. We group these two. Remember, I could have written the 9n here and the subtract 2n here, and it would still work out. Doesn't matter which order you put it in. So in red here, greatest common factor of those two would be an n with a 3n minus 2 left over. Greatest common factor for the blue underline there would be, need to get rid of that parentheses there. Greatest common factor underlined in blue there would be a plus 3, and we would be left with a 3n minus 2 there. So combine those, n plus 3 is a factor, 3n minus 2 is the other factor. Set those equal to 0 because this is equivalent to this. Now set each factor equal to 0 and solve. So I'm going to shortcut this one. This one is going to be n equals negative 3. When the leading coefficient is 1, you just take the opposite sign of this one, and that's your solution. So n equals negative 3. Then we have 3n plus 2. We're going 3n subtract 2 equals 0. We're going to add 2 and divide by 3, so we're going to get 2/3 when we're done. We'll go through the process here. 3n equals 2, divide by 3, n equals 2/3. So this parabola crosses the x-axis at negative 3 and positive 2/3. So that is it for this